maybe a new keyword. Okay, all right. So this is on page 4 of your handouts. We were comparing 2 brands of batteries. It could be anything. You could compare 2 classes, like 2 applied classes. It doesn't matter. This is a very good way of analyzing and comparing the 2, right? It could be the same teacher, it could be different teachers. It doesn't matter, but you have 2 different sets, right? And when that is the case, I would strongly recommend, and listen carefully, you could have 4 classes. You could compare 4 different classes if you wanted to. In that case, you need to just think in general what would happen in that case. Well, then I would have L1, L2, L3, and L4, right? Like, so it's, you use every column you use for every class because you kind of want to have them all together so you can compare them side by side. Okay, so this is just an example where I have 2 different things compared. Okay, A, determine the 3 measures of central tendency. So I will cheat a little bit and bring up what the answer is, okay, because I have that worked out here somewhere. At least I thought I did. Yeah, so for brand Y, I have my mean as 5.72. The median is 5.75, and that's all in years, right? And your mode is 5.9 years, and it's imperative that you arrange it. Okay, Jeremiah, at least until June 7th. So, all right. I'll be all by myself for another while there. Okay, so brand Y, that's an L2. So watch this. I still have this in my calculator, I hope. Yeah, so I have those values in there. I'm going to zoom in a little bit. I have those values all in there. I sorted both of them, right? So if you go to my main screen, I sorted in ascending order the L1 and L2. Then I go back and it's there. And so the mode should have been very easy to find if you arrange it. Right there it is. 5.9 shows up 3 times. Okay, so easy to find. It's arranged. It's there, and you got it. To find the mean and the median, right? You go stat, calculate one variable, stat. It's always going to be one variable. Okay. One variable, and then I call L2 because I wanted to do those calculations on what I have in the second column. I don't know, Jeremiah. Let us know if that works. I have a feeling that it could work. There are a lot of shortcuts that I don't know. Sometimes if you can fill me in on that, if that works, why not, right? I have them arranged already, so I wouldn't know. I will try later. Okay, let me. It will complain if it doesn't like it. Oh, it says done, and I'm gonna go check, and it hasn't butchered anything. So yeah, it probably works. Never thought of that. Look at that. Always, there's all your brains combined are much smarter than me anyway. So what can I say? All right. Well, so we've got our MCTs and the range. I will come up with the range here real quick. It's 7 minus 4.5, right? And that is 2.5 years. Okay, so I have MCTs and the range. So describe the sets distribution, determine similarities and differences. So for B, you were supposed to create a line plot. And when you're putting them side by side, you want to have the same scale if possible, right? Most likely it's gonna include everything. So I'm gonna have this here Mean median mode is labeled, right, for all of them, and they're in the general area. They're all very close together, right? You probably argue that mode should be, right, this should be pointing mode. So I agree. I use the computer to do this. I would agree with you that it should be pointing at the actual, like the three dots stacked. But just remember, you label MCTs on a number line. You tell me what those numbers represent, and it represent years. You have brand X and brand Y, okay? By observation, let's not read this just yet, but we have our MCTs, they're close together. Just look at this spread. If you did this, so I asked you to do that because I didn't want to spend time in class to do that. You can tell that brand X is more spread out. It's further away from your mean. Okay, this is your mean in this general location, and compare it to brand Y. You can see that it's clustered around mean. Just making some observations, right? That means is more consistent. What do you know about the range? Remember the range? Like if you go highest minus lowest, range is lower. So low range, meaning it's more consistent and it's clustered, right? Because you're basically taking the points, both of them have 30, you're bringing them in and you have less room to spread them around. So they're going to cluster together, right? This one is spread out, right? Spread out, less consistent. Range is high, right? So we have, let me just peek once. I'm going to look at the 5.1 years of a difference, and this one was just 2.5 years, right? So by observation, your line plot should tell you, oh yeah, look at this, spread out, the range is much bigger than this, okay? And you can clearly see clustering around the mean. So we're always comparing, where's the average? Is the data clustering around the average? Things like that. That's what the line plot, any graphic organizer, even a histogram should still show this, okay? And so there you have it. That is the way to analyze and describe them, okay? So for C, if you don't, I would ask you to write this down next to the graphs anyways. And I hope you did it, because if you don't, then I guess you won't have the visual, right? You're going to be in a not so good position, right? C, write this down, okay? If somewhere under this work that you've done, brand X, data is more spread out. We're basically saying the same thing, but now we're writing it out more spread out, which means it is less consistent and the range is larger. Brand Y, data is clustered, not so spread out, which indicates more consistency. Okay, I will add this. Points are further from mean, which is the average, right? Points are closer to the mean. And we could talk, you should, okay, got it, Jan. You should mention, okay, to understand big picture here. I talked about dispersion earlier. It's just talking about how widespread things are. I also talked about outliers. You can clearly see under brand X that you have what we call outliers, right? You have outliers on both ends of the data points, on the upper end and on the lower end. In this case, you could have only one outlier, or so. Outliers are significantly different from the rest. They're different from the trend. Versus brand wide, yes, you could argue they're outliers, but it's not significantly different. They're not significantly removed from the rest. Okay, so we talked about that, and you should also have a knowledge of that if I ask questions around that. And then D asked, uh, based on these results, which brand would you recommend? So without me even showing you the answer just yet, in this course, and I mean in just in general, you would have to agree that brand Y is better. Okay. Uh, yes, you could say it's almost like a skewed Amazon review, right? Sometimes something has 4 stars, but then you look at the individual reviews and it's like 1 star, 1 star, 2 stars, 3 stars, 5, but it's all over the place. I personally, I'm not so sure that I want to buy that because it's telling you it's a hit and miss. I don't want a hit and miss because what if I'm the miss, right? What if my product fails on me, right? So uh, I would pick brand Y because it's more consistent. It's slightly less, the average is slightly less, the lifespan, but it's more consistent. Okay. And also tell like the mode, if you look at the mode, is like the most batteries are lasting actually 5.9, so which is slightly higher than the average. So here's D for you to copy down, and E as well, because you should base it on other factors too, right? But in this course, we're primarily going to be looking at the spread, consistency, right? Range. That's what we're talking about here. D, I would recommend brand Y based on the fact that the lifespan seem quite consistent compared to X. Brand X has some battery that lasts far longer than the average. That would be the outlier. But also has some that lasted a lot less. Okay. And how do you know things are more consistent? Right? Uh, Lower range, right? Consistency is directly related to the range. Direct correlation. Okay. And then you have other factors that you would consider in your decision making. Warranty. What's the cost, right? Like if I look at Amazon, it's a hit and miss, but it's like $5 versus the brand name, which is 50 or 40. Well, then I'm willing to take the risk, right? So in reality, you wouldn't just base it on the reviews. You would base it on the cost. What is the risk, right? What are you going to use it for? Is it going to be outdoors or indoors? Um, I would I would base it on how easy is it to return, right? Like so that's just real life comparison. Um, that as a wise consumer, that's what would factor in to all of that, right? So keep that in mind. So I'm hoping you're writing this down. You can write it down right under page 4, right in that slot, or you can just add it on loose leaf and just make sure this refers to page 4, or attach it to the booklet, take the booklet apart, insert that piece of loose leaf, have it in a binder. Um, it all goes, like normally these handouts, I would give them to you as we move along, but, right, and good thing that I prepared the packages because now you have them all, right? I don't have to worry about you having to write down all those numbers, okay? So there is that, and now we're ready to talk about standard deviation. Standard deviation is gonna make all of these terms that we've talked about come together. So think about deviation. If you deviate, right? What's the deviation? How far are you going away from the mean? That's what standard deviation is going to tell us. It's going to be, we've actually calculated it all along. I just didn't show you the value when you actually calculate that. So grab your notes, right? And here we go. Standard deviation. The symbol we use is like a 0 with a little pigtail like that. It stands for sigma. Okay. So that's the symbol we use for it. Okay. So standard deviation this is the measure, okay? That tells us how far data deviates from the mean. I will just mention this. This measure is often used when comparing two or more sets of data points. Okay? So it's basically going to tell us standard deviation, which we're going to calculate, right? It will tell us if the data is spread out or if it's closer together. If it's spread out, it means it's inconsistent. If it's smaller, right, data is more consistent. Okay? So a low standard deviation means that data is close to mean, right? Data is close to mean, it's clustered, consistent, low range, right? If you went high minus low, it would be a smaller number compared to the other one. So it doesn't, on its own, it doesn't make much sense. But when you do this with all of the data points and the data sets, it does help you comparing, right? So if we look at Manitoba's daily cases versus Ontario versus Alberta versus, right, like other countries even, you can actually say, oh, we're pretty consistent with what our average is versus other countries that are all over the place. What's happening there? Are they not testing enough, right? so forth. Okay, so a low standard deviation means all of these things. Okay, a high standard deviation or a higher, right? Data is spread out. Further from the mean. I will just put not another. Further from mean, and this is in general, right? In general, that's what's going to be the case. Not all points will be far from the mean, but in general, it means that right, it's widespread, less consistent, high range. So if you take the high minus the low, it's going to be a bigger value, like the brand X, right? 5.1 years versus 2.5 of brand Y. So how about we also do this to have a visual? Maybe I'll just use a different color. So if you have a low standard deviation, I'll use blue. I should have used a ruler there. That looks a little sloppy. I'll just try to fix it. Here, 1 sec. If this is our number line, I need a red pen right here. Right? If it's a low standard deviation, then wherever your mean is, you're going to have a lot of values. Just put a bunch of points down, right? It's going to be clustered like that. Okay, one bar might be higher than the other, but you're closer. And let's say your mean is here. Your average is right there, right? So then you would see something like this appear on your line plot, so to speak. And if you have a higher standard deviation, comparatively, right, you're comparing them both and they should have the same scale. You might have, you know, most of your data points here, but you will still have scattering, right? It's more spread apart. Okay, we should technically have the same number of x's here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's okay. We're not going to focus on that. I think you get the point there. Okay. So formula. Formula to calculate by hand. The standard deviation is the square root. It's kind of scary looking. The square root of the sum of x minus x bar, all of that squared, over n. This is the formula for standard deviation. And while the average is this, sum of all values over n, right? So this is the mean. This is standard deviation. Okay, so we have our mean, we have our standard deviation. So it's scary looking, I know, but it's not that bad. You'll see. I will do one example of actually working it out by hand, but I won't have this on a test on a large scale. Like actually, I'll tell you, it's not going to be on a test. It might be on an AC or a bonus question. So if you're interested in that, here we go. Okay, so let's say you have games. and percentage. So let's say you're given a table like this, and it's game 1, 2, 3, 4, 5, and you scored 36, 41, 43, 39, and 45. Don't ask me what game. I just made this up, right? Let's find our average here, because the formula calls for average. So the average would be 36 plus 41 plus 43 plus 39 plus 45 divided by, you added 5 games, right? That is 204 divided by 5, and that is 40.8%. So you need this number to do that. So we basically use this formula. Sum of x means you add up all the x values divided by n. There are 5 in total, so we divided it by 5 to get this. The standard deviation is found by taking the square root of the sum of x minus the average. So that means that you have to, every single value, you have to subtract the mean and square that value. Okay, so I'm just going to focus on this part right here, on the top part of this equation, of this formula. So sum of x minus x average, right, x bar squared, would be, you take the 36, you subtract the average from it, and you square, plus you take the next value, which is 41, subtract the average from it, square. Can you imagine doing this for 50 values, right? It would be way too time consuming. We go to the next value, which is 43 minus 40.8, and we square that. And let's keep going. Plus 39 minus 40.8 squared, plus 45 minus 40.8 squared. That's it. So there's 5 of these that you need to account for. And that adds up to, I will tell you what this always adds up to, and I will square it. I go 36 minus 40.8, and that will be a negative. So I square it, which gives me a positive, right? I get 2304 plus, this is a very small difference, but if I square it, I get 0.04. I subtract these two, I get 4.84 when I square it, and then I get 3.24, and I get 1764. So I basically, just to show you one, okay, I go 36 minus 40.8, and then I take that answer, but you got to be careful. You got to go bracket, take that answer, bring it down, close it, and square it. That's where I got the 23.04 from. And then I did that with all the other ones. So basically, if you want to do it quicker, you do bracket 41 minus 40.8 and just put a square on top. And then you get the second value. So I'm actually entering it exactly the way I see it into my calculator to give me those values. When I add all of this up, I get 48.880. All of this. So what have I just done? I've just figured out this part right here of the formula for standard deviation. So this top part adds up to 48.8. Therefore, standard deviation, right, Therefore, standard deviation is the square root of 48.8 divided by n is the number of values that you have, which is 5. So divide these and take the square root, and then you get the answer, which is 48.8 divided by 5, right? 48.8 divided by 5, you get that. I take the square root of that, which is 3.12. And what are our units were in percent. So this is actually percent. That's our standard deviation in this case, which right now means very little to us. But if we were comparing that to a different player over 5 games and then compared those numbers, it may tell us more. Okay, now I'm going to show you how to get this a lot quicker. Take your calculator, go stat, edit, and let's clear what is in L1 and L2. And we want to find the average of this, right? So we go 36, 41, 43, 39, 45. 5 values entered. Let's find the average, like the mean, median, the way we've always done it. Right? You've entered this. Then you go stat, calculate, one variable stat, second, 1, enter. And does anybody see the 3.12? Your average is up here, which we got to 40.8, right? And you should see right here, look at where my pencil is. That's that sigma of x of the values we've considered. And that's 3.12. I don't know if you're being sarcastic, but there it is, 3.12. So let it be known, moving forward, standard deviation can just be found the way we've done everything so far. It was just hiding there. You had no idea what it stood for, but there it is, right? Yeah. So now we can move forward to, we won't be doing it by hand anymore, except for a bonus, or if you want to be ready for a bonus question, it may be a little longer than that, but if you know how to do it, they're up for grabs, okay? Let's go to the back side here. And we will now just use our calculator to find the standard deviation just like that, okay? Write this down with me. Finding the mean, right, and standard deviation using TI-84. And we're going to make it right away. We're going to go into charts, right? When presented with tables, we enter first column into L1, second column into L2. Okay, so let's say you have the salary, right? Salary of employees and how many employees actually are getting that amount. So let's say you have a chart like that and you've collected the information and you have 3,500 per month, right? There's 5 people that make that much. You have 4,000, there's 8 people, 8 employees. 4,200, there would be 2 and 4,300, there would be 5852. 58. Can you change this to a 5? I made a mistake here. It's 5852. So let's say you have a table like that, and you're asked calculate the mean salary and standard deviation. Let's say you get something like that, they ask you to find the mean salary and standard deviation. Okay? This goes into L1 and this goes into L2. And I need you to understand what this chart is saying. This chart is saying that a salary of 3,500 in your data set appears 5 times, right? So this is the frequency. This would be the frequency. Number of occurrences, right? Number of occurrences. So how many values do we have in total? Like how many salaries are we considering? So let's add it up. 5 and 8 is 13, plus another 5 is 18, plus another 2 is 20. So n is equal to 20. Keep that in mind when you have a question like this. There are 20 salaries we're considering. It's just there's some repeats, right? They repeat. 3,500, that salary repeats 5 times in our data set. So you can imagine like a big table with 20 entries, and the salaries are just stated like that, and it's just now put down into this. It's basically a frequency table, right? This is a frequency table. Let's write it down. So we go one variable stats, and we go L1, comma L2, right? Data, frequency, right? This is the frequency. So let's come up with our average and our standard deviation. Let's go ahead and enter that. Go to stat, edit, clear, 3,500, 4,000, 4,200, 4,300. Enter that into your L1. Okay. Let's go over to the other side. It's 5852. They all match. And then now you can press stat, calculate, one variable stats, one, right, L1, comma, second, L2. That's what you should see just before you perform a regression, not a regression, sorry, before you perform the one variable stats, right? And there it is. Your average is in dollars. Average salary is $39.55. Your standard deviation is 281.91, also dollars, same units. Okay, same units, it's dollar amounts. And notice that n is equal to 20. Notice that you've considered 20 values in your calculation. I hope that makes sense. Let's purposely make a mistake of not going comma L2. Let's just go one variable stats. Oops. And just call L1. If you do that, your average is 4,000. as opposed to 3955. So you're off by a little bit, you might think, but how many values have you considered? Only 4. Okay, so that would be wrong. Okay, so do not, when you have a table, you need to use L1 and L2 at the same time. Okay, so let's have a different example here. Frequency table with intervals. So this is an example of frequency table with intervals. So here you didn't have intervals, you just had a fixed amount, right? So that there's ways to do that, right? So let's say you have length and you have flowers. I'm sparing you there's actually a word problem that goes with it, but I think that you don't need it. So let's say this frequency table has been, looks like this. So you have 14 to 15, this is all in centimeters. Okay, 14 to 15, 15 to 16, 16 to 17, 17 to 18, 18 to 19. You should be able to graph this, right? If I asked you to make a histogram or a frequency polygon, you should be able to do that. But right now we're not, right? So I'm going to tell you how many. There's 2, 5, 12, 5, 1. So somebody has created this frequency table for us and just set this up. And now find the average height. Average mean is the same thing. And standard deviation of flowers. What do you do with that? You have 14 to 15, 15 to 16, and so forth. Okay. What would you do there? Anybody willing to guess what you would have to do? This is still going to go into L1. This is still going to L2. How do I get around the fact that there's an interval there? Because you can't put in 14-15 into L1. Anybody? Starts with an M, ends with a T. You need to find the midpoint. MCT. Yeah, that's close. The midpoints, okay? So in this case, it's very easy to just estimate, right? So this is 14, so midpoints. I will highlight that because, right, that happened afterwards. So the midpoints between 14 and 15 is 14.5, 15.5, 16.5, 17.5, 18.5. Okay, this goes into L1, not this. Okay, midpoints go into L1. Okay, so you need to have that nicely highlighted and that it sticks out, because if you get this and you're like, what, right? How do I find the standard deviation and the mean of this? I can't enter it, no problem. Find the midpoints. Let's say the midpoints are not easily seen. You can't see it. You can't just calculate it in your head. Like, what if it's something weird, right? I will just say to find midpoints. So this is a bullet here. To find midpoints, right? We go high, okay, plus low divided by 2. Example, 14, sorry, the high is 15, right? So 15 plus 14 divided by 2, that would be 19. Oh, sorry, 29. Never mind. Divided by 2. And 29 divided by 2 is 14.5. So if you're like, I don't know how to find the midpoint, you just add the interval, the high and the low, just add them together, divide it by 2, and you get the midpoint, right? You're basically finding the average between the two. That's basically what you're doing. Okay. So I will probably have an arrow going all the way over to my first point here. That way because these numbers won't always be as nice as they are now, where you can just say, yeah, it's 0.5, it's just in between, right? So let's go ahead and do that. Stat, edit, clear both columns for now, and we go 14.5. Oops, what happened there? 15.5, 16.5. One thing that should be clear is that the midpoints should go up consistently by the same amount. If all of a sudden you have a midpoint that doesn't fit, you made a mistake, right? And then we put in the frequencies, 2, 5, 12, 5, 1. So I'm entering those values. Then I'm going to go and calculate things, right? Second 1, comma, second 2. So one variable stats, L1, comma, L2. My mean is 16.42, round to 2 decimals, especially because it's continuous, right? Centimeters. And my standard deviation is 0.93 centimeters. And there you have it. That's all right now. Today, that's what we're focusing on. And then tomorrow we'll actually do this for two different, let's say, two different flower shops. And let's use the standard deviation to help us out and talk about the consistency, right? All right. I think at this point, I want you to go. Give me 1 second. I think I'm gonna do two things here. Homework. Page 232, I believe it is, in your textbook. So I know your textbook has been collecting dust for a while. Let me just once you're done. So this is what we just did here, and this is more now using standard deviation to compare, and that's what we're gonna do next. Okay, which is also in the textbook as question 5, 4, and 5 do what we're doing now. Okay, but let's have this page 9 out as well. Page 9 in your booklet. And right now I'm going to ask you to do something before we talk about it. This is practice. Excuse me. Okay. I will ask you to do the following. And this is now not a frequency table. A frequency table is where you have, right, an interval or an actual number, and it tells you how often it happens. Here we're comparing 5 different players, right? And so I'm going to ask you to put this into L1, into L2, into L3, into L4, and into L5, right? That's what we're going to do. And I want you to find the range, the mean, and the standard deviation for every single player. Okay? So you're going to have to go one variable stat, L1 and fill this in. You're gonna have to go one variable stats, L2, and so forth. Okay, so go ahead and do that right now. I'll give you a bit of time to do that, and I will actually give you the answer. So not much to lose here, but you need to make sure you do this so you're fluent, right, and confident with this. Okay, go ahead and do that. I'll be back in 4 minutes.